Alright, let's do this again. I just recorded this whole 10-minute video and I realized I had no sound, but we're going to do it again. So, my name is Andrew and I will be going through nonmetals for Mr. Segulin's honors chemistry class, or if you're here from a normal chemistry class or another chemistry class, this is where you will find the nonmetals. In the curriculum, it is Unit 4, Syllabus 7. And some things I will be talking about the nonmetals are where they are on the periodic table, where you can find them, what they classify, how they classify, as a nonmetal, their properties, their differences, all of that. So, without further ado, let's continue through the slideshow. What are nonmetals? So, nonmetals are gases, besides only one. Bromine is not a gas. It is actually a liquid at room temperature. So that does not count as a gas, but every other element that is a nonmetal is a gas. The nonmetals, they are brittle and they are dull. That's self-explanatory. Brittle, easily broken, dull, self-explanatory again. If you don't know, look it up. It's right there. They're to the right of the staircase, and if you have a periodic table handy, you should probably get it out. It's a lot easier if you're more visual of a learner to look at the periodic table and actually see what I'm talking about. It's kind of hard to do in your head. I mean, it's really hard to do in your head unless you're a genius, but to the right of the staircase is where you find the nonmetals. So at this staircase, you have aluminum, germanium, antimony, polonium, and tennessine. And all those five in that diagonal kind of sort of row create that staircase. Oh, boron as well. Boron and silicon and arsenic and tellurium and astatine are also metalloids. So that staircase consists of only metalloids. Everything above that or to the right are nonmetals. So that would include carbon, nitrogen, phosphorus, oxygen, sulfur, selenium, iodine, bromine, chlorine, fluorine, radon, xenon, krypton, argon, neon, helium. Also, astatine does count as a nonmetal as well. Even though it is also a metalloid, it is confirmed as a halogen as well, which is what I'll talk about later. On a different slide, we'll be targeting halogens and all that stuff too. Excuse me. So, to the right of the staircase, if I say that again, I'll be referring to the staircase more as this thing goes on. And what I mean by that is what I will show you, and there's also a visual on the last slide. So if you don't have a periodic table, do not worry. I will show you what I mean by that, and I will go through it again with the periodic table in front of me. Nonmetals are also a poor conductor of heat, and they are a poor conductor of electricity. They are very bad at doing that. They have no energy to distribute all that stuff. They do not do that well. So as we continue, where are the nonmetals found? So the only nonmetal in group 1 is hydrogen. First element on the table, all the way to the left, you find it. It is right there above lithium, first one. You can't miss it. That is the only nonmetal on that left side, and then you go across through the alkali metals, alkaline earth metals, transition metals, through all of those. You find the other nonmetals, like I was talking about, that staircase, metalloids, all of those. Semi-metals, you get through those, you find the nonmetals. Starting from carbon, go all the way through that list, like I said. So groups 13 through 16 are where you find those. All of the nonmetals there. Like I was saying, here is the periodic table. I probably keep going back to this to show you guys but here we go. Like I said, hydrogen, nonmetal. Through all these metals, metalloids, right here is where you start, and you find these nonmetals. Like I said, carbon, nitrogen, phosphorus, that whole line. Here's that staircase I was talking about. And astatine here is also a nonmetal. This is the one that was tricky before. But these are the nonmetals. So let's keep going. Get more into depth about all of these. So hydrogen is in group 1. It is a non-metal, and it is the most abundant element in the universe. It is the most important, most found, everything like that is very important in the universe, and it was first recognized as an element by Henry Cavendish, English philosopher, in 1783. He didn't discover it, but he first respected it as an element at that time, and he was the first one to do it. Some properties of hydrogen: it is a colorless and odorless gas, has no scent, no color, can't see it. It has one valence electron, and it is very highly combustible and flammable, which makes it very dangerous. Flammable, combustible mean the same thing. Combustible means it can catch fire and burn easily. Flammable, obviously the same thing. You guys know what that means. Same thing. So as we continue, group 17, known as the halogens. The name halogen comes from the Greek word for salt former. And I'm going to go to this periodic table again. Fluorine, iodine, chlorine, bromine. As I showed, it said F through AT, which is their atomic symbol. It goes from fluorine to astatine. Those count as the nonmetals, and these are all halogens right there. So bromine, which is right here, that is the only halogen, or only nonmetal I should say, that is not a gas. Like I said earlier, it is a liquid nonmetal at room temperature. The halogens have 7 valence electrons. They are very reactive because of only having 7 valence electrons. And fluorine is the most reactive. As you go down that row, they get less reactive going down the group. So as you go to chlorine, that's less reactive. Bromine's less reactive than chlorine. Iodine's less reactive than bromine. And astatine is the least reactive halogen. But they are all very reactive. And they are physically different in properties, but they hold very similar properties chemically. So they look different. They don't look any similar that they do, but if you dive deeper, excuse me, and if you dive deeper and get more chemically, they are very, very similar. And they are known to be very good oxidizing agents because they cause others to give up their electrons because of their 7 looking for that octet. And like I said before, they get less reactive going down the group. Group 18, known as the noble gases, they are right here. This will work. There you go. Right here. These 6. Helium, neon, argon, krypton, xenon, and radon rounds that out, known as the noble gases. And their name comes from the lack of reactivity. If you think of something noble, you think of something that smart. They don't do anything. They're just self-explanatory. Lack of reactivity. 8 valence electrons they have, which is why they are very low reactively, because they already have that octet. But if they do react, they form compounds with other elements. In most noble gases, they produce a nice light, which was a fact that I had in my notes and decided to put on there. And again, here's another look at the table. Hydrogen. Here are the noble gases, excuse me. And then here are your halogens. And then those to the right of that staircase also classify as nonmetals. So that's all I got. I hope that you got something out of this and were able to understand everything and get your notes done or your studying done. And yeah, I hope you have a great rest of your day.